Hi everyone. Today we're going to have introduction lecture for the topic Fourier expansion of odd and even function. Let us define odd and even function. If f of negative x equals f of x for all x, then the function is an even function. One example is here, f of x equals x squared. Second example, f of x equals cosine x. Next example, f of x equals x sine x. Another example is f of x equals e raised to x plus e raised to negative x. If f of negative x equals the negative of f of x for all x, then the function is an odd function. Example, f of x equals x. Second example, f of x equals x cubed. Another example, f of x equals sine x. Last example here, f of x equals x cosine x. There are three notes here to remember. First, even function multiplied by even function equals even function. Next note is even function multiplied by odd function equals odd function. Third note, odd function multiplied by odd function equals even function. Let's proceed with the Fourier expansion of odd and even function. If the function f of x is a periodic function defined in the open interval from negative pi to positive pi, can be expressed in the Fourier series as f of x equals a sub 0 over 2 plus the summation from n equals 1 up to n equals infinity of the function a sub n times cosine nx plus b sub n times sine nx, where the value of a sub 0 is equal to 1 over pi times the definite integral from negative pi to positive pi of the function f of x dx. A sub n equals 1 over pi times the definite integral from negative pi to positive pi of the function f of x multiplied to cosine nx, then dx. B sub n equals 1 over pi times the definite integral from negative pi to positive pi of the function f of x times sine nx, then dx. Now we have special case 1. If f of x is an odd function, meaning the f of negative x equals the negative of f of x. We have now the new values for a sub 0, a sub n, and b sub n respectively. A sub 0 equals 0, a sub n equals 0, for the b sub n equals 2 over pi times the definite integral from 0 to pi of the function f of x times sine nx dx. And the Fourier expansion becomes f of x equals the summation from n equals 1 up to n equals infinity of this function b sub n times sine nx. Then we have special case 2 if f of x is an even function, which means the f of negative x equals f of x. We have now the values for a sub 0, a sub n, and b sub n. A sub 0 equals 2 over pi times the definite integral from 0 to pi of f of x dx. A sub n equals 2 over pi times the definite integral from 0 to pi of the function f of x times cosine nx dx, while the b sub n equals 0. Therefore, the Fourier expansion becomes f of x equals a sub 0 over 2 plus the summation from n equals 1 up to n equals infinity of the function a sub n times cosine nx.